Hi kids, so now we go to the second part of our video lecture, and this will be divided into two parts. First, we will be discussing about correlations, and the second part we will be discussing about chi-square, which is the last topic outline for our non-parametric statistics. So let us start with correlations. Now, in terms of correlations, I guess you already have an idea as to what correlation means since, of course, may correlations din po na na-discuss in your parametric test. Now, correlations is represented or its symbol is actually your small letter R and that it is used to measure the strength of association. Now, when we talk about correlation, this is the type of statistics in which we try to measure the degree to which your two variables move in relation to each other. Or if we try to explain this in our own terms, so basically we are just trying to see if there is a connection or if there is a mutual relationship between two or more things. So, as mentioned here, ito po yung hinahanap natin in terms of the strength of association. And that this measure, in terms of measuring the strength of association, it would be between two variables and it may range between your -1 to your +1. Now, a -1 would mean that there is a perfect negative correlation and a +1 would mean that there is a perfect positive correlation. Now, recall this table. Yung correlations po kasi natin, other than telling you either to reject or not your null hypothesis, we need also to emphasize the level of correlation. Diba? From the name itself, strength of association, we are trying to look at kung gaano po, gaano po ka associated or gaano ka-mutual yung tinetest natin na dito sa ating data. So as you can see here, the range and then you have here the level of correlation. Now in terms of the range of correlation coefficient value, correlation coefficients here are actually indicators of the strength of the relationship between your two different values. So if very important na titingnan din po natin yung signs na whether it is negative or positive and not just the actual value kasi that would differ in terms of the level correlation in terms of how we state our level of correlation. So whether it is strong positive ba or it is a moderate negative, so we need to emphasize that one. And of course, you need to memorize this. So under your correlations, we have your Spearman rank correlation coefficient. And that, the shorter term for your Spearman rank correlation coefficient is your Spearman raw. And it is the non-parametric equivalent of your person R, or also known as your person coefficient. So here in your Spearman rank, from the name itself, so it uses ranks to determine if there is a relationship between two variables. And as mentioned a while ago, we are trying to look at the strength of association between your two variables. Now, this is how we are going to state your null and alternative. But then again, di po exclusively na dapat ganito. As long as the thought is there, then that is still correct. So for your null hypothesis, there is no correlation that is existing between the two variables. So for your alternative hypothesis, a rank correlation exists between two variables. Okay. So now let us proceed with our examples. As you can see here, I already encoded in your Excel kung ano po yung ating problem. Now, this is actually with regards to the diameter and height of a tall tree in which we are trying to see if there is relationship between the height and of a tall tree and their diameter. Now, still we will be using our level of significance, the 5%. So, the same thing, you just press data, then click megastat. Hindi pa pala, basta click megastat, and then you will be able to, ito po pala, data, click megastat, and then lalabas po ito na tab, search for the non-parametric test, and then click for your Spearman rank and order correlation. So, yan po yung nakalagay. Hindi po Spearman row, hindi po Spearman rank lang. So, Spearman rank and order. That still mean the same thing. So, once you click that, ito po yung lalabas na tab. Now, very simple lang po yung tab. You just need to input your data, kung ano po yung data values or data set nyo, and then just do not forget to tick also correct for ties and output rank data so that we will be able to see how this data set will be ranked. Ano po yung smallest number natin, ano po yung highest. And then just click OK, and then ito po yung lalabas na sa ating output. So, the first thing that you need to check is this one. Bale, baka mag-ask kayo na, ma'am, bakit iba? Bakit ganito po yung numbers na lumalabas for our data and height? And in fact, ganito po yung numbers na naka-encode. Now, in your Spearman coefficient output here in Excel, hindi niya na po ini-emphasize yung numbers, yung encoded number or data nyo. It just automatically will tell you na yung nakalagay dito, ito po yung first, yung pinakauna na encoded value nyo, siya po yung 8. So, let us try to check. So, let us look at diameter here. Now, yung number 1 daw is yung nasa second to the last. So, if we will try to look at here in our encoded data, sino po ba yung nasa second to last? And that is 442. And in fact, if you try to double check all the numbers encoded here in your diameter, si 442 talaga yung smallest na number. And that is why it is considered as your first. So, how about here sa height? So, as you can see, yung may highest na number natin is placed at the second. And if you try to look at here, yung nasa second natin is si 321. So, may mas malaking number pa ba ni 321 dito kay height? Diba? Wala na po. So, it is correct that this is our 10th rank. So, meaning, accurate po uh, yung ating result dito in terms of the ranking. So, now let us look at the critical value and your correlation value. As you can see here, you will not be able to see any p-value. And this is actually the limitation of your megastat and also in terms of using your Excel, since for our Spearman, no p-value is being shown. So our next question here would be, how would we be able to interpret or make a decision whether to accept or reject your null hypothesis? That is, the answer to that is this one, by looking at the critical value. Now, as you can see here, there are two critical values. Now, of course, that would depend on the level of significance that we are trying to look at. And since stated a while ago, we are using the 5% level of significance or your 0.05, so dito po tayo titingin. So in short, the critical value that we will check is the positive negative 0.632. Now, let us try to look at this table. This table tells us the coefficient value that we need in order to compare it to your critical value and make a decision. So, bale, diba, may makikita po kayong tatlong values dito. You have your 1.00 here, this one, your 1.00 here, and you have your 0.115. Now, ma'am, saan po kami titingin? Saan po dyan sa tatlo? Of course, dito po kayo sa 0.115. Why? Siyempre, what we are trying, diba? What we are trying to look at here in your Spearman rank correlation in our data, if there is a relationship between your diameter and height. Now, it would be expected that in here and in here, perfect po talaga yan siya, perfect 1. Since, try to look at sa table, di ba? We are trying to compare diameter to diameter. We are trying to compare height and to height. And of course, since we are comparing it to itself, then syempre, perfect correlation talaga siya. You will get a 1.00. And since what we are trying to discover here is the strength of association between diameter and height, thus ito po yung titingnan natin the value, your 0.115. Now, how do we know whether to reject or not your hypothesis? By looking at the coefficient value and the critical value. Now take note of this one. If it is less than the critical value, then do not reject the null hypothesis. So again, if it is less than the critical value, then do not reject the null hypothesis. So based on the output or the date or the result that we have, should we reject or not? Since our correlation coefficient here is 0.115, which is less than your critical value na si 0.632, then meaning to say, we will not reject the null hypothesis. Okay? So meaning, there is a uh, there is a relationship between diameter and height. Now, the next thing that we need to look at is the strength. So remember, we need to look at once again here, ito pong ating table for us to know the level of correlation. So saan po ba si 0.115? So 0.115, since wala po siyang negative na sign, so that is considered as positive. So ito po siya. So meaning to say that there is a very weak positive relationship between the height and the diameter of tall trees. So that is how we state our conclusion. Other than saying our decision in terms of not rejecting the null hypothesis, we need to also include in our conclusion the level of correlation. So please do not forget na pag correlation, pag Spearman rank, pag Pearson R, dalawa po dapat talaga yung laman ng conclusion nyo. The decision as to whether to reject or not your null hypothesis and the level of correlation. Okay. So now we proceed to the second part, which is our runs test. Actually, kani very easy lang pud kayo ni siya. But what is the runs test all about? Now, here in our runs test, we are just actually trying to look at if the data that we obtained is truly random. Oh, ing ana lang siya ka-simple inyuhang runs test. We only wanted to know if the data that we have obtained from a sample are truly or is truly at a random. Now, how do we define run here? So, try to look at this one. A run is a succession of identical letters preceded or followed by a different letter or no letter at all, such as the beginning or end of the succession. Now, in order for me to clearly explain the meaning of this, so dun ko na lang po i-emphasize pa further once na i-present ko na po yung examples para mas ma-picture out nyo pa siya. So, runs test determine the number of runs in a sequence of events rather than the frequency. So, for example, for example, you are given the number of males or females. Run test does not consider the question of how many males or females were selected in a certain data. It only shows us number of runs lang in a sequence or how random it is present in our data. So what are the assumptions for your runs test? So the data from the sample are arranged in the order in which they were selected, meaning to say, if ito yung pagkakalagay mo sa data mo, if ganito yung pagkaka-encode, do not rearrange. Huwag nyo siyang i-group. Like for example, yung example ko kanina regarding male and female, huwag nyo pong i-group lahat ng male, huwag nyo i-group lahat ng female. Again, whatever it is in your data, encode it in the same way. And then each letter, number, or event can be classified into one or two mutually exclusive categories. Okay, so for you to understand it better, let's have this example. So the entitled gender of train passengers. So on a commute, let me just read the problem. On a commuter train, the conductor wishes to see whether the passengers enter the train at random. So he observes the first 25 people with the following sequence of males and females. So ito po yung ating sequence of event. So ito po yung sinasabi ko na in terms of how it is placed, when you encode it in the Excel, it should be the same sequence. And then test for randomness at level of significance 0.05 or alpha 0.05. So this is how we are going to state our hypothesis. So for your null hypothesis, the passengers board the train at random according to gender. For your alternative, they do not board the train at random according to gender. So again ha, yung mga null and alternative hypothesis po natin, it does not necessarily, di po necessary na ganito po yung pagka-state. Again, you can have your own way of stating your hypothesis in such a way na andun pa rin yung thought, na nandun pa rin yung keywords nyo na tulad po nito, since we are trying to look at the how random your data is, then emphasize the random word. So let's proceed. Now, ito po yung run na sinasabi natin. Kanina, 'di ba? How did we define that one? So balik ko lang po. 'Di ba? Run is a succession of identical letters preceded or followed by a different letter or no letter at all, such as the beginning or end of the succession. Now, how will you know if this is a certain run? Ganito po siya. Itong pagkasunod-sunod po nito is actually based on this one. Now, if we try to uh, know the number of runs here per identical letters. Meaning to say, so tulad nito, FFF, then male. So meaning, you stop at the third F, then that is your first run. Since ibang letter naman po yung next. So itong MM, this is your second run since ang next na letter is different na. So next nito, yung apat na F, isang run. And then since dito, so makita nyo, isang male lang, 'di ba? Female na naman yung next. So meaning itong isang male that is already one run, itong isang female that is another count ng run. So ito po yun siya as emphasized here. Sunod-sunod lang po yan siya. So for us to double check if there is really 10 runs here in our data. So here, ika-6. Here, yung apat na naman na F, this is your 7th. Dalawang M, this is your 8th. Tatlong F, this is your 9th. And the last two is your 10th run. So, tama po ba yung nasa table natin on the left side? Yes, it is correct. So, I hope naintindihan siya kids ha. So, for example, gagawa ako dito, ganito. So, kunwari yung pagkaka-random ng data nyo, ganito. How will you count that one? So, again, group the identical. If yung next is different na, then wag isali. So, this is your first run. Since ito isa lang, considered as another run. And then ito, dalawa, then this is your third. Ito, isa lang, then that is your fourth. Ito, dalawa, this is your fifth. Then since ito, pa isa-isa, then 6, 7, and 8. So that's how we count our number of runs. And also, let me just emphasize that dalawa po yung examples na dalawa po yung example na i-present ko po dito in terms of the runs test. Kasi depende siya sa data din na meron kayo. So, sige lang. Ito yung first na example. Very easy to encode your or to shift this one into a number sign kasi nga in terms of your runs di po pwede na naka letters. You need to transform it into a number so for us to be able to get the p value, and that is why as you can see here naka-title lang po yan ng binary ha, but actually you can label it another way, pero since sa akin mas naiintindihan ko po kasi in that label. So that is why I placed binary there as my label. So yung ginawa ko lang po dito, F here for me is equivalent to 1. M for me is equivalent to 2. So that is why, as you can see here, I transpose the letters into a number. So, lahat po ng females ko, that is number 1, as you can see here, sa binary na part, lahat po ng males ko, I transformed it into number 2. So, once you are done transforming it into a number, now you go to Megastat. So, click Data, click Megastat, search for Nonparametric, and then may makikita po kayo ito, Runs Test for Randomness. You click that one, and ito po yung lalabas. Now, as you can see here, meron po tayong input range. Now, the question here would be, ano po yung ilalagay ko dito sa input range? Of course, that would be yung na-transform nyo po into number. Yan po yung kailangan natin. And then, wala na po kayong ibang gagalawin. You do not need to check for, ito po, you do not need to, we do not need this continuity correction. You do not also need this probability distribution. But for the sake of showing you as to what will appear if you check probability, ay, hindi ko po pala nilagay. Doon pa po pala sa isa. Sige lang, later na lang yun ha. So again, you do not need to check that one. And then just press OK, and then ito po yung lalabas. Now, how to double check? So as you can see here, ito po yung number of runs. Ilan po yung number 1, ilan yung number 2. So again, si 1 natin is si female, si 2 is si male. And then ito po yung total number of females and males or yung frequency niya sa ating data. So if you try to count it here in our binary, actually there are really 5 runs for female and 5 runs for the male. Or if you want to double check, dito na lang po tayo titingin para mas easy to check. Diba? So, how many runs yung female? 1, 2, 3, 4, and 5. O, diba? So, yan po yung number of runs na nakalagay dito. Diba? 5, 5. And then, kamo na lay mano-mano og count aniha. Basta tama na siya na ay 14 ka females and na ay 10 ka males. So, unsa nga tong tan-awon? Of course, that would be your p-value. So our p-value here is 0.2516, which means it is greater than 0.05, meaning to say, we do not reject our null hypothesis. So in short po, the passengers that is actually boarding the train is really at random according to gender. Okay? So how about this one? This is our second example. So again, medyo tricky itong second na example, but what is actually the difference? So before answering that question, let me read first the problem. So the title of our example here is Ages of Substance Abuse Program Participants. So let me read. 20 people enrolled in a substance abuse program test the claim that the ages of the people according to the order in which they enroll occur at random at alpha 0.05 and the data are as follows. So our null hypothesis here is that the ages of the people according to the order in which they enroll in a substance abuse program occur at random, whereas alternative is it does not occur at random. Now, going back to the question, what makes this example different? To answer that question, look at your data set. Kanina po kasi naka-categorical siya na in terms na may gender kayo female, male. And all we did is to transpose it into numbers, which is very easy since you only have two categories. And automatically we could just transpose your categories into numbers. But here, since numbers yung data set nyo, paano natin siya gagawin? Kasi for the runs test, hindi po pwede na maraming numbers. You only need to have 2. Just like what we did in the previous example na, di ba, 1, 2, female, male. But how about this one? How are we going to transpose this na magiging 2 categories na lang siya na naka-binary or naka-numbers pa rin? So let us take a look at this example. The first thing that you need to do in order, just like as you can see here, diba, naka-transpose na ako ng 1 and 2. But how did I do that? The very first thing that you need is to get the median. Siyempre, I think Kabalo naman mo ana, 'di ba? Equals median and then you just highlight all your data set just to get what the median is. Now, our median value here is 27. So, what will we do next? Hmm, ito. In order for you to be able to transpose your data set here into numbers, two numbers na lang na 1 and 2, ito po yung function na gagamitin natin. Itong if equals if. Now, yung lalabas by the time you click, you type equals if and then your open parenthesis, merong nakalagay logical test, value if true, value if false. So you can see here, in terms of the logical test, what we need to place here is ganito. If yung value natin dito, which is 18 na nakalagay kay A2, so if A2, again, A2 there is referring to number 18, which is our first data value. If A2 is greater than or equal to your median. Dito po ito po yung reason why kailangan nyo si median for us to have a certain point na ma-differentiate or mag-group natin yung data value nyo, either greater than or less than. So if your data value is greater than or equal to the median, so dito kasi nakalagay yung median value natin sa G2. So kaya lagay nyo G2. If uh, if A2 is greater or equal to your median, then kama nyo place 1. Meaning to say, kasi 'di ba nakalagay dito value if true. So yung true na ginamin dira if mao ba na ang atuang i-transpose sa number saya, and since what we want na kung greater siya or equal, then dapat ang gawas na number is 1. Here, if value is if false, kung less than siya, then ikama lang na ang gusto nato na magawas is si number 2. So once you enter that one, ang lalabas na dito na value nyo is number 2. Why? Try to look at 18. Is 18 less than or greater than your median, which is 27? Of course, it is less. And that is why lalabas ito kasi, diba, it is the false of our logical test na ang nilagay natin is greater than. So since it is less, then dito po siya sa 2. And then, drag nyo lang po yan, drag nyo lang pababa, and then, na-transpose na po natin siya into your two numbers na lang, which is 1 and 2. Once mahumantaan na, now we go to our third phase in which we need to count the number of runs. So by this time, dali na lang. Diba, ang number of runs since 2121 na lang man siya. So as you can see here, I already counted the number of runs. So of course, since 212 man then counted as 1 runs each. So 1, 2, 3. And then since ang next diri is, diba, until diri man ang before nag-change ang value, then another run, 4, 5, 6, and then 7, 8, and then 9. Puntahan, nasabtan ninyo. If there are any questions, please do not hesitate to post in the content or discussion forum. Okay? So, since we already have our transposed numbers, so the same thing, click data, click megastat, click nonparametric test, and then click your runs test for randomness. And then ano po ulit yung i-highlight? That would be your transposed or kaning sa under sa binary na label na ko. And then wala na po kayong ibang gagawin. Wala na pong itik. All you have to do is just highlight and then press OK. So ito po. Now, how to make sure? Diba, how many our total number of runs? Diba, tama po tayo. May 9 runs here in our data. And then, eto na din agad, number of runs na may number 2 and then may number 1. And then, frequency, and then total number of data. And then, here is our p-value. Now, before we check our p-value as to whether to reject it or not, ipapakita ko lang po, dito ko po kasi pala nilagay in terms of yung probability Yung ito, probability distribution na part, this one. So, let me just show you na if i-click nyo yan, meron pong lalabas na ito po na table or ito po sa output nyo. Actually, if you are doing a manual computation, this is what you need to do. Then again, be glad na naatay mga software na and naatay Excel that can actually do our computations. So all you need to do is just to click and remember what to click and what to place. Then, di na nato na kailangan. Pero kani, gusto lang po dyan ako siya ipakita sa inyo ha. Then again, do not need that one, so let's proceed. So again, let us take a look at our p-value. So our p-value is 0.3776, which is greater than our level of significance. We do not, therefore, we do not reject our null hypothesis. So meaning, our data really occur at random. Okay. So I hope nasabtan. So this is actually a summary table in terms of all our non-parametric tests in terms of katong atong na-discuss. Actually, chi-square is really a different matter naman din. But since there are chi-square tests that is under non-parametric statistic, so natin separate or include nato siya na separate discussion. Then again, for this one, na nagani chi-square diri. So, mao na ni siya. Another table to read for you to understand better each of your different types of hypothesis testing. The example, your variables as to what measurement scale or what type of variable it is. So whether it is ordinal, continuous, so mga ganun. Okay, so we leave this one for you to read. So, let us now go to the last part of our non-parametric statistic or last part of our topic, and that is your chi-square. Now, again, there are a lot of types of chi-square tests, and I guess na ay chi-square na na-discuss sa inyong parametric test. But here for our non-parametric, there are 4 different chi-square tests that we need to discuss. So we have your test for goodness of fit, test of normality, test using contingency tables. And under using contingency tables, meron po tayong dalawa, which is your test for independence and test for homogeneity of proportions. Now, it may sound complicated or it may look like parang ang dami, but this type of test is literal. So, kung ginamina literal, whatever is in the name of your test, that is actually what it is trying to test. So when we say test for goodness of fit, what we are just trying to look at if it fits in or if it fits a certain category. When we say test of normality, we are trying to look at if there is normal distribution. If it is test for independence, then we are trying to look at independence. Nga na siya, as in literal. So the tricky part lang po dito sa chi-square test is for you to understand your data and try to look at what is being asked. Pero syempre, as long as you have your keywords there, like for example, does this fit mga ana or is there an independence in terms of mga ingana? So that is already your keywords. And that is one way for you to know what type of chi-square you need to use. Okay? So let us start with your test for goodness of fit, for goodness fit. Now for your goodness fit, it used the goodness of fit test to decide whether a population with an unknown distribution fits a known distribution. Di ba? Literal. Used when you have one nominal variable with 2 or more values. And this is our assumption for goodness of fit test. Data are obtained from a random sample and the expected frequency for each category must be 5 or more. Then this is how we present our null and alternative hypothesis. But then again, it's not exclusively like that. Again, you have the freedom to in terms of how you will state your null and alternative as long as it means the thought is there. So the population fits the given distribution. For alternative, the population does not fit the given distribution. So in this case, there will be a single, usually for goodness of fit, there will be a single qualitative survey question or a single outcome of an experiment from a single population. Usually, ganun yung case ng goodness of fit nyo. Either single qualitative survey question or single outcome of an experiment from a single population. So let's proceed to our example. So, kunwari ganito. Suppose, pumunta kayo ng isang supermarket or sa grocery. And then you wanted to see whether yung mga kunwari kayo yung nagbebenta ng mga fruit soda which had these 5 different flavors. So you have your cherry, strawberry, orange, lime, and grapes. Now, you wish to see whether yung mga customers nyo may specific na preference among these 5 flavors. So what you did is that for a certain day, you counted each of the yung mga kinount nyo po kung kung ilan yung customers na bumili nito na flavor, and then you have such data. So for cherry may 32, kay strawberry may 28, kay orange may 16, lime 14, and then grapes 10. Now, what we need to do next is to get the observed and expected frequency. Now, since here if since wala po akong sinabi na specific na expected na number, so pwede po ganito ang gagawin. So ito ha, if in case there is no expected frequency mentioned in your problem, all you have to do is to total your number of samples and then divide it by the number of categories that you have. So for example here, if we total this, may 100 po tayo. So, meaning 100 i-divide nyo into 5 since may 5 categories po tayo dito or may 5 flavors. And then, what will you get? Diba? 20. So, yan po yung gagamitin natin na expected frequency. Meaning to say, we are trying to expect that for each flavors, so the flavor that you are selling, there is at least 20 individuals that will buy it. And here for the observed, ano yung actual? Ano yung actual data? Ano yung actual number of people that really bought that certain soda flavor? Again ha, if hindi lang po talaga na-mention yung expected. But there are problems which really mentions number of expected frequency, then you use that one. So, our question here would be, are these differences significant? Or is there a preference that is existing? Or are they just due to chance na kaya sila bumili niyan? It's just a chance. So, how do you state your alternative and null hypothesis? So, consumers show no preference for flavors of the fruit soda, and for your alternative, consumers show a preference. So, how do we process this one? So, as you can see here in my Excel, this is how I encoded my data. And the usual, click data, click megastat, click. But this time around, hindi po tayo sa non-parametric test mag-click. May makikita po kayo dyan, which is just above your non-parametric test, which is chi-square. Click chi-square, and then you will find these 3 options. Since you are trying to check for the goodness of fit, then click goodness of fit test. Once you click that one, ito po yung makikita nyo. You will see that you need to input the observed values and the expected values. So since naka-group naman po yung ating observed and ating expected, so just highlight that one. So for observed, highlight your data here. For your expected, highlight this data. And then here, number of parameters estimated, syempre yung itatype nyo po dito is 20 since that is what you are trying to since that is what you are expecting in terms of your expected frequency. So, type 20 there. And then, ito po yung lalabas. So, bale, itong nakikita nyo po dito, which is this one, this table, this is how you are going to compute your chi-square goodness of fit if you are doing it manually. But since, then again, naman tayo Excel, automatic na siya muhatag sa inyo ha. So, all you have to do is to look at your p-value. So here, since we have a p-value of 0.0012, which is less than your 0.05, then meaning to say, reject your null hypothesis. So it means to say that your consumers really show preference in terms of the flavors on the fruit soda that you're selling. Okay? Sige, next. Now we proceed to the test of normality. So for the test of normality, it is used to test a variable to see if it is normally distributed. O, di ba? Again, literal. Tinitingnan lang po talaga natin yung normality, if normally distributed yung inyong dataset. This is how we are going to state our hypothesis. The variable is normally distributed or the variable is not normally distributed. So it involves finding the expected frequencies for each class of a frequency distribution by using the standard normal distribution. So in terms of this standard normal distribution, actually ano siya? Formula dun sa Excel nyo. And then actual frequencies are compared to the expected frequency using your chi-square goodness of fit test. So remember this one. If the observed frequencies are close in value to the expected, then your chi-square test value will be small and your null hypothesis cannot be rejected. But if there is a large difference between your observed and expected, then your test value will be larger. Then of course your null hypothesis can be rejected. So kung iisipin nyo, just by looking at your expected and observed frequency, you will already have an idea as to, or kumbaga parang may expectations ka na in terms of what will be the result of your p-value. So, for test of normality, it can only be used if, so ito po yung assumptions natin, if your expected value for the number of sample observations for each level is greater than 5, your data is randomly sampled, and the variable you are studying here is categorical. Now, test of normality is not actually that powerful. In fact, there are other alternatives to your chi-square test for normality, which is way, way better. And these are the following. So you have your Kolmogorov-Smirnov, your Lilly-Force, your Shapiro-Wilk, your Kramer-Von, D'Agostino, and your Harkebera, if that is how it is correctly pronounced. But for each of these tests, syempre naghihapon ni sila kumbaga specifics. But then again, di ko na po ito i-include sa ating discussion since di rin naman natin siya magagamit sa Excel nyo. Since in your Megastat, we do not have these functions. Kung nag-SPSS pa siguro ta kids, then expect na ma-introduce ko din sila sa inyo ha. But then again, we have these limitations. So, di na lang po nato siya i-push through. Okay? So now we go to your example. Now, for the test of normality, medyo complicated siya. Medyo complicated pero depende sa inyuhang problem. But the problem that was presented in your Bluman was this one. 'Di ba? Complicated siya in a sense that we were not given a raw data. So muna na natay certain step-by-step today kay again what is important here is to get the observed and the expected. Now if you are given this certain example, how do we know what is the observed and what is the expected? Right? So muna na before we are able to use katong inyuha gihapong megastat, then we have some things that we need to follow first or we need to do first. So let me just read the problem. Use chi-square to determine if the variable shown in the frequency distribution is normally distributed. So you have your boundaries here and you have your frequency. And the total number of samples here, or total frequency here is 200. So meaning to say we have 200 data values. The next thing that Bluman presented is this one. So, dara ang inyuhang hypothesis and na certain manual computations na gibuhat diri and apart in order to compute for your mean and SD. So, as you can see here, this one is your middle value. Kani, ito, middle value from your boundary. Then here, as you can see here sa symbol, meaning to say, si middle value multiplied by the frequency, kani kay gi-square ang inyuhang middle na value multiplied kay frequency. So actually, kailangan siya, as you can see here, ginagamit na siya na values in order to compute for your mean and SD, which is one of the values that is needed for us to compute for the to compute for your expected frequency. So as you can see here, sa book kay Bluman kasi agad-agad pinakita to siya. Yung observed tsaka expected. Now, question, asa gikan si observed? So you can see observed comes from, eto po, your number of frequency. Diba? 24, 62, 72, 26, 16. Later, i-explain ako ng 16. Ha? Yan, basta, we'll explain why naghimo na siyang 16. The question here now is where did we get the expected? Diba? Again, once walay observe, labi na walay expected, then we will not be able to compute for the p-value in your megastat. So, ganito po yung ginawa natin. So, you can see here, eto given. O, basi mong tanong na, ha, ma'am, asa man na given? Mo ni siya na part. Diba? Frequency, middle value, atong gi-multiply, and all. So, mo na siya. Ang kailangan nato makuha is kaning gibox na ko og red. Your z-score, the area, and your expected frequency. So, dara nato na siya makompute. So you can see, ito ha, as mentioned, you need to get your mean and SD, and I think you already know how to do that one. Diba? Makuha ganig po na ninyo by using your descriptive statistics na option. So once you get your mean and SD, let's proceed with this one. In your z-score, di ba remember the definition for our test for normality that we are using your normal, standardized normal distribution. Meaning to say, for your z-score, this will be our formula. So, you write there equals standardized. And then, ano po yung mga values na kailangan nyo? X here refers to your middle. Your middle value, which is this one, kaning inyuhang XM. And then next, you place your mean, which is this one, and then your standard deviation. So once i-enter na ninyo, mugawas ni siya na z-score, and then drag down para na ay z-score tanan. Next, how do we get the area? Now, to get the area, dara na siya, equals norm s dist. So, dara na ang katong standardized normal distribution. So, as you can see here, once you type that one, na mo gawas na z. So, z here represents for the z-score. And then, kaning cumulative ninyo, all you need to do is place true. Actually, true and false man daw ni siya. I tried to search what exactly cumulative means. And by definition, so let me just read it ha. Cumulative is a logical value that determines the form of your function. If cumulative is true, then your standardized normal distribution returns the cumulative distribution function. If false, it returns the probability mass function. Actually, wala kay nako ni siya na ano gyud kids ha kay I tried to look into what is this probability mass function, but then again, dili jud ginagamit ning false na option. So let's make our life easier. So just type there true. And then lalabas na po ito the values. So, yung normal as this ninyo, kanilang na na-valuehan. Now, ma'am, ano na is second na area? We need, di ba, the area that we mean here is the area under the curve from the value of your kato inyuhang boundaries. Now, since kaninyong boundaries, di ba, maumanin yung boundaries. Now, nga doon na atay second na option sa inyong area. Since in your boundaries, naka-range man gud siya, dili man gud siya specific na value, then we also need to get that certain range. Muna na, ang mahitabo ani kids, of course, diri na part that is the same since it is your first na value. Sa mga next, minus-minus na siya. So, meaning, ang inyong ibutang ani, so kunwari si 0.4094 minus 2, kani 0.1335. So, pabaliktad. So, kani sa next, 0.7427, i-minus ni mo dira kay 0.4094. Kay nga naman, sa inyong boundary, sunod-sunod biya siya, di ba? Di ba? Tanaw na to usab. Di ba? Naamo dira 89.5 to 104.5. 104.5 to 119.5. So, muna na i-minus lang siya dito sa previous to get ang katong inyuhang middle area. And then, once nahumana na ninyo, then we are able now to compute for your expected frequency. Now, how do we compute for your expected frequency? That is, kanina area, again, kanina na area, na katong naag minus-minus ta, minus-minus, i-times ninyo sa kaning inyuhang, wait lang ha, let me just double check. Sorry kids. Bale, for your expected frequency, kanina area, i-times ninyo na siya sa total frequency. Pila tong total na frequency? Total frequency is 200. So meaning to say, your 0.1335 is multiplied by 200 and this is the number that you get, which is now your expected frequency. So basig mangutana mo na, ma'am, what if day isa lang ka-value ang ato ang or wala nato siya gi-range ang ato ang boundaries? Then of course, dili na ninyo need ni na magkuha pa og difference. Since pa isa-isa lang siya, then automatic na kanina dayon. But since dito magud sa example na gihatag ni Bluma naka-boundary, then we need to do this. We need to get the difference, ang range ato na area jud ato mismong range. So now we have your expected frequency, then we will be able to ito. Then we will be able to compute for your p-value. Now, with your test for normality, as mentioned a while ago, you can make use of your goodness of fit. Actually, wala lang na ako na siya napakita diri. Pero pwede to siya, input ninyo ning observe, input ninyo si expected the value, and kanina na p-value ang ato ang makuha. As you can see, the p-value here is 0.14392. 0.14392, which is greater, diba? Greater than your level of significance na 0.05. So, meaning to say, dili i-reject. So, meaning our variable is normally distributed. As simple as that. Unsa ni siya? If nag-manual ta kids, this is how we are going to find your z-scores. As you can see here on the round letter Z. Then again, since wala man ta nag-manual, so mao na pasalamat ta na naggamit ta ni sa inyuhang Excel kay at least dili mo magmano-mano og tan-aw dito sa inyuhang table kani sa inyuhang z-score. 'Di ba? Okay, kani sa area manggod ni in order for you to know the area. So para makita ninyo, for example kani 0.65. O napoy actually limitations paggamit ani kay since kani manggod is up to 2 decimal places lang, then we cannot get the exact values pa. So mo na basig magug inyuhang tan-awon, magka-slight difference gyud na siya sa area na value nato diri kay since here ang z-score magud nato is nag-consider pa ta og more than 2 decimal places. So for example, kanino 0.6518. So inyo lang nang tan-awon 0.6 diri mo sa diri na ang first na ah na digit ninyo diri tan-awon na siya kani sa inyong right side. So since that is 0.6, dara. And then next, pangitaw ninyo ang second na digit, di ba 0.65 man kaya to. So, dara man si 5. So this one, so that is 0.74. Tama ba? Dara. Di ba? So 0.7427. So ingana na siya, mano-mano. So now we go to last two. Kamay na lang yun. Test using contingency tables. Ngano na siya ginatawag og test using contingency tables since if your data can be placed in a contingency table as literal as that, then you can make use of this one. So we have your test for independence and test for homogeneity of proportions. So for independence, used to determine whether two values are independent of or related to each other. For your test for homogeneity, so used to determine whether the proportions for a variable are equal when several samples are selected from different populations. So for assumptions for both independence and homogeneity is that your data should be obtained from a random sample and the expected value in each cell must be 5 or more. So let us start for your test for independence. Now, you are given this example in which a researcher wishes to see if there is a relationship between the hospital and the number of patient infections. So a sample of 3 hospitals was selected and the number of infections for a specific year has been responded. If you try to read the problem, iba mura siya kanang correlation. Okay, you are asked about the relationship. But then again, try to look at the question here. At alpha 0.05, can it be concluded that the number of infections is related to the hospital where they occurred? From there, you will get an idea that what we are trying to look at is not actually the relationship. Diba? Ito nagatanog relationship diri. Ang atoa lang is kung unsa. What we are trying to ask here if there is, kumbaga if there is difference in terms of opinion between the two groups, or if there is difference in terms of number of infections in the 3 hospitals. So, this is how we state our hypothesis. Number of infections is independent of the hospital or it is dependent. Diba? Test for independence. So, this is how I placed my data. So, the usual, click data, click megastat, click, and of course, dito gihapon mo sa chi-square, and then namoy makita na kani, contingency table. So, you click that one, then all you have to do is to highlight your data points. Of course, do not include the total. Dili nato na siya kailangan. So, highlight ang kani sa inyong data. Wala mo'y lain po na hilabtan diri kids, only the chi-square, and then click OK. Then, ingani ang gawa sa inyong output. So, wala mo'y laing tanawon, p-value lang. And from your p-value, careful ha, nabi na nakabutang na e negative 0.6. So, say pasabutan na, meaning exponential. Meaning, daghan na ka nag 0.000, ana. So, makakita pa lang gani mo dayon og e negative or e dira, then that would mean to say that it is less than your p-value. Meaning to say, we will reject. Meaning to say, meaning to say that it is not independent of the hospital. Eh, di ba? Kung tanawon biya lang nimo po sa problem, kumbaga mura siya kanang, say tamang term na kinsoy, kanang medyo common sense in a way na ang infection, di man gyud na siya, magdepende man gyud na usahay, di ba, sa hospital kay in terms of patient management or in terms of the hygiene or kanang unsa ka dalas gyud na kanagong unsa ka sterile ang mga gamit na ginagamit sa hospital. So that is why dependent yun na siya. For me ha, not exclusively, dili 100%, but still it could be an add-on factor. Okay? So for our last na, test for homogeneity of proportions. Now, samples are selected from several different populations. Let me just read, ha. And the researcher is interested in determining whether the proportions of elements that have a common characteristic are the same for each population. Remember the word homogeneous. Iba mo na homogeneity. Homogeneous. When we say homogeneous, it means that it is the same. Whether be it in structure, composition, basta they are the same. So, this test gets its name from the null hypothesis, where we claim that the distribution of the responses are homogeneous or the same across all groups, same for each population. So, for example, a researcher may select a sample of 50 freshmen, 50 sophomores, 50 juniors, and 50 seniors, and then find the proportion of students who are smokers in each level. The researcher will then compare the proportions for each group to see if they are equal. So, kana lang, di ba? From that statement, you will, kanang kumbaga magets ninyo na you're just trying to look at if it's the same or not across the different groups. Diba? Homogeneity. So, given this example, let me read, ha. A psychologist selected 100 people from each of 4 income groups and asked them if they were very happy. The percent for each group who responded yes and the number from the survey are shown in the table. So at 0.05, test the claim that there is no difference in the proportions. So you are given this data and this is our null and alternative. Now, dili dapat ingani inyuhang null hypothesis, ha. You need to transpose this into sentence. Ha? Pero kana lang just to present and just to make it shorter, na kana ma-visualize ninyo dayon. So we are just trying to say here that all, uh, itawag ani, sa 4 income groups, equal lang yun na sila tanan na happy. Or, sa inyuhang alternative na at least one na nailahi. So, the same, this is how this is how I encoded your data. And then, the usual, click data, click megastat, click chi-square, and then yung ano nyo pa rin, yung contingency table ang i-click, and then input only your data, kanilang do not include total, then you will get this one. Then you will have your p-value here, moro man dyan natong tanawon diri na 0.0027. Since it is less than 0.05, then we will reject your hypothesis. So, meaning to say, it is not the same. Sa tanan income group ninyo na happy sila na ay naglahi. As simple as that. And that actually ends our discussion and our non-parametric statistic topic. So, this is just actually a summary of your chi-square. Kani? Just for you to understand better pa as to the difference of those 4 na chi-square na atong na-discuss. So we leave this one for you to read and then try to synthesize. So I hope you learned a lot. If there are any questions again, please do not hesitate to place it on the discussion or content forum. And reminders lang po kids, since I know this is a very long discussion and that is why dili ninyo ni siya pwede i-cram. And unta, by this time around, you will realize that yes, biostatistics, bio-epi is actually a difficult subject. That even I myself, tabi na katong start pa lang sa nag-handle na ako ni na subject, it is really very challenging. And that is why, sana lang kaya mo no, sumuna na please, 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 gamay effort lang, studyhan ahead of time para at least mahinay-hinay kaya di pud ni siya in one sitting manggod. So I wish you all good luck and God bless. Thank you for listening, kids. Have a great day.